Okay, folks, we're going to dig in now a little bit into the idea of electron shells. You've seen drawing of a carbon atom before, electrons whizzing around the nucleus of the carbon. They look like little plants going around a sun. That is not the newest, latest, or most interesting version of an atom, but it's good enough for us. It's called the Bohr model. Or Bohr model. That's Bohr. It's just the name of the chemist who proposed this back in the day. More modern ones have like a fuzzy cloud of electrons and around the nucleus and probability and funny shaped orbits. They call p like a p orbital or things like that. Don't worry about it. This Bohr model, yes, it's older. This planetary looking model is older. It's good enough for us. It works well enough for the anatomy, for the biology. This will do. So here we have a nucleus, which they just put C for carbon and O the nucleus. You know that's made out of individual protons and neutrons, but whatever. Around this, we have electrons, and I want you to notice they are in layers. And that's the really important thing here. Electrons in the Bohr model are arranged in layers. And we call each one of these layers a shell. So you're looking at 2 electron shells in carbon. Shells come in different varieties. The one closest, the first shell, can hold 2 electrons. The second one can hold 8. The third one can hold 18, and you probably want to memorize those numbers for testing purposes. But 2, 8, 18, know that. Think of carbon. Carbon, has 6 protons. You know that because there's 6 for the atomic number on the periodic table, so it has 6 positive charges. If it is a neutral atom, like most atoms start as neutral, it's going to have 6 electrons. And what you see here is 6 electrons. But that's 2 in the inner layer because that's all it can hold. It can only hold 2. So the other 4 are the layer outside. So we still have 6 electrons to balance the 6 protons, but we have to do it by putting them in 2 layers. An inner layer of 2 and an outer layer of 4. This atom is balanced. We will be talking about charged ones that gain and lose electrons. We'll get to that. But we need to mention the outermost shell has a special name. It's important. It's worth remembering. It's called the valence layer. And the valence shell or valence layer, because it has the outer electrons, those are the ones that are going to interact with other atoms. They're the ones that control the chemical properties of that atom and what it wants to do when it's around other atoms. So they're super important. The valence shell, the outer layer, that's the most important shell. You can see that this inner layer here has 2 electrons. Well, guess what? That layer is full. The outer layer here is 4. That's not full. The only reason I'm mentioning this is because atoms all are trying to achieve full or 8. Helium, because helium is atomic number 2, it's got 2 protons, it only has 2 electrons, but the outer layer is full, so it's happy. I want to make sure you understand. If you want to think of the noble gases, the ones on the right side here, that column, those are contented atoms. They're happy. Their outer layer is either full or 8. Everybody else wants to be them. Everybody wants to get to full or 8 for their outer layer. And that's great. Let me give you an example. You already saw helium is a happy atom. So let's look at neon. Neon is atomic number 10, has 10 protons. You know that from the square on the periodic table with the atomic number 10, 10 protons. And those are arranged in 2 in the inner layer and 8 around the second layer. So it has a full inner layer and a full second layer. That's a super stable atom because it's happy with the full and then it's happy again with the full around the outside. It doesn't really need to interact with any atoms. It's got everything it wants in life. All right. I've already said The first layer can hold a maximum of 2. The second layer can hold a maximum of 8. The third could hold a maximum of 18. Let's look at argon here. 2 in the inner layer, 8 in the outer layer, that's 10. 8 in the third layer, the very outside layer, the valence layer. All right, so argon has 2, 8, and then 8 again for the valence layer. You might think, oh, well, if we went to the next number, we would just add it to this valence layer and then have 9. But no, atoms want 8 if they can achieve it. And argon's got it. And if you are the next thing up on the table, if you're 19, if you're potassium, you've got 2, you've got 8, you've got 8. And even though that third layer could hold a maximum of 18 and you only have 8 in there, you're still going to push the potassium to the fourth layer all the way. It's going to be in the fourth shell. The valence shell has only 1. Why? Well, because your plan is to become an ion. Your plan is to get charged. What do I mean by that? Your plan is to push that ninth one to the outside and then throw it away. Interact with anything else that'll take electrons, and you give it that electron, because then you'll be happy. Then you'll have 8 in your outer layer because you lost that ninth electron. You will lose this electron and shove it to some other atom, and then you'll be happy because you have a nice stable 8 and a nice stable 8 and a nice full 2, which is also stable. That makes you really happy. But if you do that, you have 19 protons and only 18 electrons. There's no longer a balance, and there'll be an overall charge at that point. Anyway, and that's how we create an ion, a charged particle, a charged atom. Any atom that gains or loses electrons is an ion. And we'll talk more about that. But the thing I want you to get here is electron shells and the fact that atoms want to have full or 8.